Today we're going to cover the theory behind shock waves, how shock waves are created in air. Same phenomenon happens in water, we call that bow waves. Okay, so when do shock waves occur? Well, when the source is traveling, let's say you have an aircraft, when the velocity of the source, if the velocity of the source is greater than the velocity of sound, that is when the shock wave is created. So let's see why this happens. So let's give this some numbers so you can make more sense of this. So let's say the velocity of the source is 400 meters per second and the velocity of the sound is 340 meters per second. So let's treat the source as a point object so we can visualize it a little easier. Okay, so imagine the source looks like this. Okay, at t equals to 0, that is its location, and then it starts sending out a sound wave. The sound wave is traveling at the velocity of sound, centered at where the source is, right? But the source is traveling faster than the sound wave, right? So at t equals to 0.5 seconds, how far will the source have traveled? The distance of the source is going to be the velocity of the source times t. The velocity of the source is 400 times t, so that is going to be 200 meters. So the source will have traveled 200 meters, and it is here, 200 meters. And then the distance of the sound wave, this is the distance of the source, is going to be the velocity of sound, 340, right, times a half, and it's going to be 170 meters, right? So in 170. You see the sound wave is trailing behind the source. So now at t equals to 0.5, it releases another sound wave, right? Traveling like this, starting to spread like that. But it's still moving faster than it. So let's say at t equals to 1 second, right? The distance of the source is going to be 400 times 1, so 400 meters. So in 1 second, the source will be here. And then the distance of the sound is going to be 340 times 1, so it's going to be 340. So then this sound wave is going to be travel like this, and it's going to be, this is going to be 400. So 340 will be somewhere here, like this. The wave that was made at the half-second mark will have also traveled 170 meters, right? So since the source was at 200 meters, 170 would take you to 370, like here. And then so it's going to make a circle like this. And it's going to be the same size that the sound wave was when it was made at t equals to 0, right? So that one is going to be 170. So you can see that what is being made is like a cone. We can make a cone like this. Like this. So all the sound waves that are made intermediate between 0 to 1, there's a sound wave that was made at 0.1 seconds, 0.2 seconds, 0.3, 0.4, 0.5. I'm only concentrating on 2 of them, right? So there's a bunch of sound waves made, but all the sound waves are trailing behind the source. And the source is always going more distant than the sound waves, right? So this cone that is made creates the shock wave, right? So this also happens in water. If a boat is going in water and it's going faster than the water waves, so the same thing will occur. It will go like this and it will create a cone like this, like that. So this angle here, we can calculate this angle theta. So look at, if you concentrate on the theta here, you have a sound wave like this. So this distance from here to here is 400, right? And the 340, right? From here to here, 340. So this is 340. So if we make a triangle like this, you can see this is theta, this is theta. So you can concentrate on that like this. You can say this is 340. And this distance is 400, and we can make a 90-degree angle. So this cone is the tangent line of the spherical shape that the sound wave has made, right? Because the sound wave travels in a spherical fashion. So this cone that is made is tangent to that sphere. So this angle right here is 90 degrees, right? So we can say this angle is theta, and then you're gonna get a certain number and we can calculate what the theta is. But what's the principle behind that? Let's generalize this now. The 340 was the velocity of the sound times the time interval. Velocity of the sound times the time interval. And then the 400 was the velocity of the source times the time, right? Velocity of the source times the time. And then the time and the time cancel. And then sine of theta is going to be V sound over V source. That theta is known as the half angle of the apex made by the cone, right? So this is the half angle. Half angle of the apex of the cone. Okay? But that is true for all of the sound waves that are made in the intermediate region, right? So you can say, you don't just have to focus on the sound wave that was made at t equals to 0. Let's look at the sound wave that was made at t equals to half. The sound wave that was made at t equals to half, that has also traveled 170 meters, right? 170. The rocket traveled from t equals to half to t equals to 1, right? The rocket has traveled 200 meters. And then so if we look at the cone, we see that that's still the same angle. Right, this is theta, and then this is 90 degrees, right? So we can say sine of theta is equal to 170 over 200. Well, 340 over 400 is the same as 170 over 200, right? So it's still the same ratio. So all of the sound waves intermediate between t equals to 0 to t equals 1 still make the same cone, right? As long as the velocity of the rocket has not changed. Right? If the velocity is constant, the angle of the cone stays the same. So now I'll give an example of how to use this in a problem. Okay? Thank you very much.